Good morning, my dear students. Welcome to physics class today. Let us discuss about the importance of this velocity time graph. Okay. So, there is a graph in your text, that is page number 35. It is a velocity time graph. In that graph, you can see x-axis and also y-axis. Now you can see that graph in the screen. In that, it is a graph which shows a uniform velocity. An object moves in uniform velocity. യൂണിഫോം വെലോസിറ്റിയിൽ സഞ്ചരിക്കുന്ന ഒരു വസ്തുവിൻ്റെ ചലനത്തെ സൂചിപ്പിക്കുന്ന വെലോസിറ്റി ടൈം ഗ്രാഫാണ് നിങ്ങൾ കാണുന്നത്. Its velocity is 10 meter per second. And how we can find out the displacement from the graph? Displacement of the object between second and 8th second. രണ്ടാമത്തെ സെക്കൻഡിനും എട്ടാമത്തെ സെക്കൻഡിനും ഇടയിലുള്ള ആ വസ്തുവിൻ്റെ ഡിസ്പ്ലേസ്മെൻറ്റ് നമുക്കൊന്ന് കാണാൻ ശ്രമിക്കാം. We know that velocity is equal to displacement by time. Therefore, displacement is equal to velocity into time. That is very important. Then in this graph, it is equal to AB into AD. See, what is AB? AB is the time interval between 2 and 8, 2 second and 8 second. രണ്ടാമത്തെ സെക്കൻഡിനും എട്ടാമത്തെ സെക്കൻഡിനും ഇടയിലുള്ള സമയ വ്യത്യാസമാണ് ഇവിടെ AD എന്ന് പറയുന്നത്. So, in this graph, time is equal to AD and velocity is equal to AB. Okay. So, we can say the displacement, that is velocity into time, is equal to AB into AD. AB into AD means a side into another side, vasham gunam vasham. That is the area of ABCD. This is equal to area of the portion under the part BC of the graph. So, it is very important that you have to understand that. So, you must understand that displacement of a body within a definite interval of time is equal to the area of the portion under velocity time graph. From this graph, you can understand that under BC, the area under BC is area of ABCD. Actually, that is the displacement of the object. Okay. Now, let us find out the equations of motion from these graphs. First equation of motion, that is V is equal to U plus AT, that we already discussed. നമ്മളത് പഠിച്ചതാണ്. പക്ഷേ അത് ഈ ഗ്രാഫിൽ നിന്ന് എങ്ങനെയാണ് കിട്ടുന്നതെന്ന് നമുക്ക് നോക്കാം. Please carefully watch this graph. This is the velocity time graph of an object traveling with the uniform acceleration. It is a freely falling stone that is given here. ഒരു സ്വതന്ത്രമായിട്ട് താഴേക്ക് വീഴുന്ന ഒരു കല്ലിൻ്റെ ചലനം സൂചിപ്പിക്കുന്ന അതിൻ്റെ വെലോസിറ്റി ടൈം ഗ്രാഫാണിത്. ഇത് ഒരു യൂണിഫോം ആക്സിലറേഷനിൽ സഞ്ചരിക്കുന്ന ഒബ്ജക്റ്റാണ്. താഴേക്ക് വീഴുന്ന ഒബ്ജക്റ്റ് ആകുമ്പോൾ അത് യൂണിഫോം ആക്സിലറേഷനിൽ സഞ്ചരിക്കുന്നതാണ്. ദെൻ ഹിയർ യു ക്യാൻ സീ PQRS. And also one more thing you must understand, S and R. S is time t1 and R is time t2. So, we are finding out we are getting the time interval between 2 second and 4 second. So, 2 second is t1 and 4 second is equal to t2. t2 is represented by the point R and t1 is represented by the point S. And also the first velocity, initial velocity of the object is 20 meter per second. So, you can see that point is P and final velocity is Q, that is 40 meter per second. It is represented by the letter Q. And we are drawing a perpendicular from P to QR, that point meted the QR is A. So, carefully watch all those things and understand that. I will read out that also. Draw a perpendicular from T1 and T2 to the graph. They meet at point P and Q respectively. Then draw another perpendicular QR from P. It meets at A. Consider the trapezium PQRS. It is very important. We are considering a trapezium PQRS. Actually, why we are considering it? If we want to understand the displacement of the object in between P and Q, what we have to do? We have to calculate the area under PQ. Okay, let u be the velocity of the body at time t1, that is initial velocity, and v be that at time t2, that means that v is the final velocity. In the graph, the points P and Q corresponds to u and v respectively. We know that P is representing initial velocity and Q is representing the final velocity. Then Ps is equal to AR, that is equal to u. Then QR is equal to final velocity v. Then SR is equal to T, that we can represent like T2 minus T1. So, T2 minus T1 is equal to the T. Then AQ is equal to QR minus AR. Carefully watch that figure, then only you can understand it. AQ is equal to QR minus AR. That is equal to V minus U, final velocity minus initial velocity. So, that is very important. Then equation showing velocity time graph, how to find out acceleration from a graph. What is the difference in velocity in the time interval SR? Is it not AQ? If so, how can we calculate the acceleration? We know that acceleration is equal to change in velocity by time. Acceleration is equal to change in velocity by time. Here, change in velocity is AQ and the time is SR. So, what you can write? We have found out AQ is equal to V and AQ is equal to V minus U. And also SR is equal to T, the time taken for the change of velocity. Then acceleration A is equal to V minus U by T, so that AT is equal to V minus U, or V is equal to U plus AT. This is the first equation of motion. So, we are getting V is equal to U plus AT from the graph itself. So, that is another importance of this graph. Then we will get all equations of motion from the graph also. So, it is very important to understand this. So, what you have to do, you carefully watch the figure and try to find out the values, and from that we are getting the first equation, V is equal to U plus AT. This may not be asked in the examination to write the equation, derive the equation, but you must remember the equation. Okay, thank you.